Hello guys, sorry I got some internet issues. I hope everything is going well and you started to hack with on your project and with the Giza tools. Here the idea of that session is first to answer your questions or doing a debugging session if you have any questions on the new tools that we launched the last few weeks. And also Ege and Jakub will give you an overview of the Giza datasets, which is an SDK that we just launched a few days ago. And the idea is to use created dataset for the blockchain. Maybe let's start with questions. Then again, Jakub, you can talk more about the Giza dataset, and then we can come back to questions and debugging session if you have any other questions.
Yeah, so sure, that makes sense.
Okay, good. So first of all, anyone has a question or wants to share a bug that they have? Here, I'm gonna share with you the link of the documentation. So in that documentation website, you have 4 documentations. You have the datasets documentation, the AI actions, the workshop that we did last week. So the AI action is a Python SDK that we designed to facilitate the creation of workflow in the KML. So the idea is that you can create your workflow in Python and you stay in your Python environment and you can make verifiable and unverifiable predictions. So this is what you have in the AI action documentation. Then you have Orion. Orion is a framework that we created, which is writing in Cairo. And this is how we make your model verifiable and provable. So what we do exactly, we take your model from ONNX, we transpile it to Cairo, and then you can use it. And we also support EasyKL. So you have the choice between Orion, Cairo, and EasyKL, which is another ZKML framework. And then you have the documentation of the Giza platform, which is the Giza CLI, where you will be able to create a user, to create a workspace, which is a UI to interact with your AI actions. You will be able to transpile also your model. So you have 4 main documentations that will depend of your needs, of course, but I wanted to share with you that link. Any questions or bugs that you would like to debug? If not, also I'm gonna send to you the link of our Discord channel. The Discord channel is of the Giza Discord channel, where you can discuss about your code, and we can help you to debug it. I'm gonna send it to you now. Okay, so maybe let's jump to the datasets overview. So Ege or Jakub, do you want to talk about it?
I can give like a quick introduction of what we have done so far. Do you mind if I share my screen?
Sure, you can do it, or I need to give you the.
I think I can. Can you guys see it? I think you can. Okay. So this is the documentation we have for our datasets SDK. It's relatively simple because it's now like the first version of it. But basically, it gives all the introduction in regards to installation, quick start, etc. Just to go over the quick start page, which is, I guess, the most important one. Here, we obviously need to install the library before, but after installing, we import it by this command. And then this is the tricky part. For some computers, it doesn't need, but if you're using your local computer, then probably you'll have this error where it will fail to authorize basically. So you need to add these lines of code for you to get your authentication. After being authenticated, you need to obviously instantiate your dataset hub object. And with that object, you can basically run everything in regards to both exploring our current datasets as well as loading either an individual dataset or a subset of datasets. These two sections go in more detail about what hubs specifically does or what loader specifically does. By the way, you can also use our website to explore all the datasets that currently is available for you to download. Here we have both protocol-specific datasets. For example, this would be for Aave protocol for version 2 of it, a dataset that has basically each deposits and borrows down to any given pool in a daily basis. It is aggregated, and here you can see what you sort of approximately can expect from the data. Yeah. If you have any questions in regards to, I want this protocol, I'm interested in these types of data, please send us as feedback. I think it's really important for us to know what you prefer and what type of data sets you expect in the future. I can also quickly show how this looks like in production. Oh, I think we have a hand raise. Yeah, go ahead, please.
Hi. Very good work, guys. I was looking at your datasets, and it came up in my mind the project yield aggregator that compared the yield ratings on compound and balancer in a few liquid pools, and also using yield tokens. And with a simple button, you could check anytime from the web page if there were some updates in the aggregated yields, and you could change the investment that you were making within the pool of the. That could be very easy to do with all that data aggregated that you have.
Absolutely. Do you have a sort of like a data provider website in your mind that is able to provide that aggregate data of
Oh
all?
no, that was an exercise that we have done for a Solidity course. Okay, it was a yield aggregator, and we're speaking about 2 years ago. Okay, so it's probably out of date at the moment. But the idea was of aggregating a couple of sources from smart contracts, swap smart contracts. I think one was compound, and the other one was balancer. And we did we catched the yield, the percentage of yield, and while catching it, we were comparing it using the wallet of the person that was connecting the wallet to the aggregator. And there was a conditional, and we decided what was the most useful, the most
So I agree. Like, I think as you know, as we increase the amount of sort of different data sets that are available in our library, the amount of sort of different interesting tasks or like machine learning models that we will be able to build only using those data sets will be obviously exponentially increased. I think right now we don't have, obviously what you were talking about is really interesting. For that, I guess the challenge for us right now would be to sort of like compare or like aggregate between different networks. What we need to do is collect all of them individually and make sure that there's like one sort of structure in which all these different yield protocols data would fit, and then convert all
Yeah.
these data sets into that specific data. I think it's sort of like an interesting, yeah, go ahead, Jacob.
Hey, yeah, so I'm also from the Giza team. Just to give you like more context, I think there is one data frame that has some of the data that you're looking for. So within the aggregated data sets, there's one, I forgot the exact name of it, but there is one, yeah, top pools API for protocol, exactly this one. And so with this data set, you have some data on like the API being yielded by different pools. It's across multiple chains from where I played with this data set for a bit. And if I remember correctly, most of the data is for the Ethereum mainnet. So if you wanted to do like a comparison between multiple different chains, you might struggle to find enough data to actually compare between chains and like within the instances of the same protocol across different chains, right? But yeah, like there's quite some data on APIs in different protocols. Yeah, so you could probably start this sort of analysis, this sort of a model that aims to optimize the API by like reshuffling the portfolio composition with that data set.
And you think it would be more interesting for you to build a yield aggregator, which is the final product, or maybe it's more interesting to have more data from different protocols, like using the graph, for example.
Yeah, for sure. I don't remember the exact number of how many projects and how many chains are in this data frame, but it's definitely like the number of rows is definitely in like tens of thousands or maybe even hundreds of thousands. So it's quite a large data set already.
Okay.
Yeah, but like I agree. It's definitely like a really interesting use case to try to use ML to optimize for higher yield across different protocols. Yeah, so that's like a really good use case that you're thinking about, I think.
Okay. Thank you. Very good work.
Glad to hear that. Thank you.
So I guess I can quickly also show how it looks in a sort of like a Jupyter notebook, which I assume most of you guys will use at some point. We obviously import the data sets. And then here you can do, if you prefer, you can go to the either the web page for docs or here you can read the source code. It's relatively easy to understand. And I think it's well documented. You can see all the different functions you can call using the loader or the hub. Here we can see that we can take, like, for example, print all the tags that are available. Maybe we're interested in a task that is specific for interest rates, or maybe we're more interested in only data from Arbitrum. We can use any type of these like different tags and sort of search through the existing dataset library accordingly. We can also list basically all the data sets. This obviously is a bit impractical because there are a lot of, but what I think most of you guys, I assume, would use in some point would be to say, okay, I'm only interested in data from Yearn V2. Let me look at all the data sets that have it, right? And here there's like a listing. You can see the individual documentation for that data sets, its tags, its description, and also our GCC sort of link to our cloud. Yeah, and after choosing any of these specific data sets that you're interested in, loading is very, very simple. You just initiate the dataset loader object, and then you say loader loads and give its name, and it should work out. If I don't think we have, but there's also sort of another loading function, which is multiples. Let me find it. Multiple. I don't think, I'm not sure, Jakub, perhaps I might be wrong, but we don't have any sort of data sets that you need to call this function yet to download. But anyways, if you have any questions regards to like how to operate these different SDKs, please write us any like comments, feedback, questions, etc. Also, and we are very interested in the data sets that you are expecting us to provide in the near future. So if you have any feedbacks or like any comments or any opinions, please tell us, and we would love to answer it. Yes, go ahead.
Yeah, I have a question. If I want to create a data set, can I create my own data set and contribute to the open source project or not? What's the process?
So currently, there is no like, open way for you to either permissionlessly or permissionally publish the data sets. This is something that we are working on. The reason it's currently not implemented is only because, this dataset SDK basically came out 2 weeks ago. But I think that's definitely something in the future that we should develop. I think there will be sort of 2 different iterations of that. One will be where you will, I guess, send us the data set and we will check it, and we will sort of give you either permission or not. But the second iteration will be sort of more like, I guess, Kaggle or like Hugging Face, where there will be sort of like a social medium of data sets coming up, people publishing, maybe through some type of like incentivization mechanisms to make sure that people are invested in dataset creation as well as usage. But for now, if you have any data sets that you think would be useful, please, just get in contact with us, and we would love to also publish that data as well. Thank you all for listening.
To contact you, we have in the Discord channel, in the Discord server, we have a channel specifically for dataset.
Exactly. Thank you.
There is a question of Nestor. If you want to answer it. Oh, no, sorry. About the idea that could be exciting for this hackathon. Okay. The idea of Giza actions is to create workflows. So it's more like use cases that you could create. Okay, there are a bunch of use cases in like medical ZKML. I'm gonna share with you a very good project made by a team that we granted. What's the name? Medical. So I'm searching. Yeah. So that's a very good project made by a team. They created medical ZKML diagnosis website where you can have prediction of your based on some symptoms, and all models are verifiable and provable. When they built that platform, we didn't launch that action SDK, AI actions. The idea is to easily create your workflow. So yeah, you can do some use cases in medical field, in finance, of course, and you can combine. It could be also interesting to see the combination of what Ege just share with the data sets and AI actions, where you can build financial use cases with that. there is also, I think there are a lot of interesting use cases in social media. You see with Twitter now, like it's not transparent at all and not decentralized at all. So there are some interesting use cases where you can build ZKML algorithms for social media. There is another project that is really interesting. They created, I will share with you Orion usage. It's all usage that was built by different teams with Orion. And in that document, I think it's in the bottom, you have some use cases built by builders. And there is a project really interesting called ZKML Solar PV. And they created a solar PV hardware with ZKML inference. That is really interesting. But again, at that time, AI action was not released, so they used Orion by himself. But you could simplify a lot the workflow with AI action. I don't know if it answers your question, but in that Orion usage, you have a bunch of different previous hackathon projects and use cases that was made and you can take inspiration into it. Any other questions? Okay, so if you don't have it, yeah, can we have a workshop of? Yeah, sure. Okay, so let's talk about Giza actions. We did a workshop of Giza actions last week, but I can talk about it now. For diffusion model, we are a bit far from that because we didn't implemented transformers yet. I see that there is Charlotte in the chat. She implemented the convolution today, I think so, in Orion. So soon it will be implemented in the transpiler, so you will be able to transpile your ONNX model to Cairo code. But yeah, for diffusion, we are a bit far from that. But of course, if you want to build build one, you can just create the operator in Orion. Orion is fully open source, and then the missing operators, and then we can support it in the transpiler. In the workshop, Jill, I'm not sure in which one you talked about it. Yeah, maybe. I don't know in which workshop we talked about the stable diffusion, but yeah, we are not ready yet for supporting stable diffusions. Basically, out of few example package in the Giza models in Cairo package, there is vanilla example where they can put Cairo code, Starknet contract being called via. Yeah, so for the Giza models to be supporting in a smart contract, it's really easy. The only thing that you have to do is to I'm gonna share my screen. The only thing that you have to do is to encapsulate it with the smart contract requirements. So for example, here in the Cairo book, in Starknet smart contracts, you have the documentation of creating a contract. And the only thing that you have to, so I'm gonna share that with you. And the only thing that you have to do is to encapsulate your the Orion Cairo code with the requirements for creating a smart contract, the storage also, and the tensor, which is an object that we are using in Orion, is already supporting smart contract requirements like CRD, etc. So it should work. But I can create an example and share that with you in the Discord after the workshop if you want. Okay, so now let's me talk about AI action quickly. So about the action SDK. So the action SDK is a Python SDK. The idea is to create from scratch your workflow and make your workflow verifiable or unverifiable depending of your project. So let's see how it works. Here, the idea is to do it with, I'm gonna give you an example with the MNIST data set, okay? So we will use PyTorch to create our model and we'll use the MNIST data set. So the MNIST dataset, if you're not familiar with it, it's like the hello world in machine learning. You have digital digit here, okay? You can, and the idea is to make the prediction of one handwriting digit. Sorry.
Hi, Rafael.
Yeah.
We're still seeing the Cairo book program.
Oh, okay.
Website.
Okay. So, are you seeing my VS Code now? Great, thank you. Okay, so I said that MNIST dataset is a handwriting digit dataset, and the idea is to make the prediction on that handwriting image. So, so first, before to create actions, what you have to do is to log in to the the Giza platform. So to log into the Giza platform, why? Because you will create a workspace, which is an UI. I'm gonna talk about it in a few minutes. To log into the Giza platform, you first need to install the Giza CLI. Okay, so this is the command. And then what you have to do is Giza create users, and me, I'm gonna do, because I already created a user, I'm gonna do Giza users login, and I'm connecting to my account. Okay, then I suggest to you to create an API, so an API key, so you don't have to relog every 2 hours, I think. So let's create API keys. Okay. Then once your API keys are created, you will create workspace. So the idea of a workspace is to have a dashboard, a UI, where you will be able to see all your actions and your deployments. So let's, okay, this is created now. So let's create a workspace. I already created a workspace to my user, so I can just get my workspace with that command. So Giza workspaces get. I don't know why it's so slow today. Okay, at that link, I think it's my internet. Let us know if it's really slow in your side so we can improve it. Yesterday it was really fast, but I don't know why it's so slow today. Okay, so the idea is that is to have a UI, a dashboard where you can see your actions, your deployments. Okay, so let's first dive into what is an action. Before to create actions, we will define our model for this for this prediction. Okay, so here we will create very simple model. We will first resize to 14 by 14, which it will be much faster for the prediction in Cairo. Then we'll create very simple neural network, as you can see, linear layer, a ReLU, second linear layer. And then we will resize the image, and then we can create tasks. So the idea with task decorator, you need to import task from the Giza actions, okay? And the idea of tasks is, as it's in the name, you know, you create a task for your workflow. So the first task that we want that the workflow does is to prepare the data set. So here we will prepare the data set, we'll download it, we'll split it between train set and test set. Then we'll create another task to create loaders. So let me just run it. So I create loaders, and now I create another task to train my model. Okay. So here I'm defining the task to train the model. I'm defining a task to test my model. And now what I need to do is to action that task. So I'm adding that action decorator. And by adding that action decorator, it will execute the task that I defined in my action. And I can see the logs, but I can also see it in my dashboard. Okay, so here in the dashboard, I see all the tasks that I defined in my action. I see the logs. Okay, and here I can have an history of all my actions. Okay, now that we did that, you can also deploy an action. The idea with deployments is to deploy your action and action it asynchronously. So for example, if you don't want to run it directly, you can deploy it. I cannot do that with the notebook. So we have to create a PyTorch, a Python script for that. But if when you deploy it, okay, so let's maybe deploy one. Python shell Python deployments. So I deployed, the code is here. The code is exactly the same, you know, that we just show, that we just saw. We have the task, we have the action, and to deploy it, we just create an action object and we serve it. The action object is from the Giza actions, okay? And we just serve it. And by doing that, at that link, we have a deployment, which is here, okay? And I can run it whenever I want, okay? I can do a quick run. It's pending and it will start now, okay? So it did exactly the same thing that we just saw, but now with asynchronous run. Okay. Now, what we want at the end of the day is to make it provable, right? So what we will do, I'm gonna share with you a bit of the Giza stack here. Maybe, no. Pages, Giza stack, okay. So how it works. You are building your action SDK, okay? Then what we will see in a minute, we will take our model, our PyTorch model, and we will transpile it to first convert it to ONNX. And then from that ONNX model, we will transpile it to Orion Cairo code, okay? And because it's transpiled to Cairo, we can make it verifiable. So we transpile it to, we will transpile it, and then the action from the action SDK, because it will be deployed in Giza platform, we will be able to make ZKML inference and prove it directly. Okay, so this is how it, the full Giza stack. So first we have to convert it to ONNX. So again, I'm converting that to, I'm creating a task and I converted that to ONNX. This is what I do here. And then I action the task. This is what we do here. Now so here I redid the full process. So that's why we train and create, but you can just convert it from the pre-trained model. Then now that your model is converted to ONNX, we want to deploy it. We want, sorry, to transpile it to Cairo. So to transpile it to Cairo, you will use again the Giza CLI. So to make it, you will do Giza transpile. You have to give the ONNX file that we just converted, okay? So generated, so transpile, it's in examples, verifiable mnist.onnx, and then I want the output path. And I want to call it verifiable mnist. Okay. this will start the transpilation. And by transpiling the model, what it will do, it will check first if there is a model that was already created with that ONNX file that you provided in your user account. If the model was not created previously, it will create a model in our platform. If the model was already created, it will just increment a version. So it will just we will just have a new version of it, and that's really helpful if you want, for example, to dive more in a specific version of your MNIST model, and you want to just transpile a new version of it. So now the transpilation is ready. I can see it here, okay? And here I have two directories. I have inference and initializers, okay? In inference, you have the Cairo code of my inference model. And in initializers, you have all tensors that are used in your inference model. So let's just see how it looks. So here we have the first layer, the second layer, and we import the weights, the biases of my transpilations, of my initializers. Okay. Once my model is transpiled, I want to deploy it to the Giza platform. In order to deploy it, very soon we will add a feature to deploy directly your transpile model. But sometimes, because the transpiler doesn't support all Cairo code, all operators, sorry. Sometimes when you transpile a model, the transpiler will tell you, okay, this is the transpiled model, but there is that operator that is not yet supported. And we didn't want to return an error. Why? Because we wanted that you can dive into your Cairo code in order to make it compile if we don't support the operator. So what you have to do to deploy your model to the Giza platform, you have to do a Giza, you have to dive into your transpiled model, CD verifiable MNIST, and to the inference directory, and you just compile it. So you do scarb build to build your scarb project. Scarb is a project manager in Cairo, and you have this inference.sierra here in the target dev directory. Okay, then what you have to do, you only have to do Giza deployments. Giza deployments, I give my model ID, I think it was 19.3 and version ID 3, I think. And then you give the inference. I cannot do it now because I already did it, but this is what you have to do to deploy your model. Once your model is deployed, you will be able to run your program in verifiable mode. So when you use the verifiable to false, it will just run the ONNX model. When you do the prediction, you put the verifiable to true, it will run the Sierra file. And by running the Sierra file, it will also generate, it will run your Cairo program in the Cairo VM, and it will generate the trace and the memory files that are very important to prove your program. And what we do under the hood, we take the generated trace and memory files, and we start a proof job, okay, for you, so that you don't have to prove it again. And then you can just download your proof with, I'm doing that fastly because we don't have a lot of time, but then you can download the proof, okay, that was generated under the hood in our platform, and you can easily verify it again with the Giza CLI like this. If you want to generate the proof by yourself locally, what you should do, you should take the Sierra file that was generated and use the Cairo VM from Lambda class to generate the trace and memory files, and then use that trace and memory files to prove it. And you should use the platinum prover from Lambda class again to prove it and to verify it. We wanted to make an easy to use tool for you, so you don't have to deal with that part. But if you want, you can, of course, generate the proof locally. And this is this is the idea of the Giza Action SDK. The idea is that you can stay at much as possible in your Python environment, and you don't have to deal really with the Cairo code. Of course, if you want to make some changes in your Cairo code, or if you want to make it as a smart contract, you can dive into your transpiled model. But the idea was to create workflows in Python, and we wanted to abstract as much as possible the ZK part. I see that there are some questions, so maybe I'm gonna check it. Okay, sorry, I took a bit of time, but that's it. If you have any questions, let me know. Yeah, Jill, so any model can be converted from PyTorch to ONNX, okay? ONNX is an open source framework that is famous in the machine learning industry. And what we do with Orion is that we are building in Cairo all operators that are supported in ONNX. We didn't reach the 100% of operators yet, but this is the idea, and this is why I told you that we cannot yet support the stable diffusion for the moment. It's because there are some operators that are missing. But if you want to support it, to use it in your model, you just have to see which operators from ONNX you need to create a stable diffusion, and see which operators we support in Orion, and you just implement the missing operators. Okay. Okay, guys, I think I reached the time. If you have any other questions, join the Discord channel, and I'm gonna be I will be happy to answer any questions, guys. Okay, so see you guys.